Okay. So yeah, so last class we had factored this. Those were the three factors that we found. Now, what we're going to go to is, if you weren't given these hints, how could you find one? How could you factor it if you weren't given hints? Like in this example, we checked all of those binomials. Some of them we used the remainder theorem and found the remainder was 0. Some of them we used synthetic division and found the remainder was 0. But we found out that 3 of these were factors and this one wasn't. And an equation that has an x cubed can have at most 3 factors. It's sort of like, you know how we FOIL with binomials? Well, with multiplying by 3, it still works out that the first one matches up with all 3 first ones. And the last one matches up with all 3 last ones. There is just a whole bunch of outsides and insides in between. I don't know if you want to call it FOIL if you want to, but there's a lot of arrows going on in between. But the idea that your first ones still give you your x cubed, your last ones when they're multiplied will still give you 12, that's the hint for how we factor these if we weren't given ones to try. Which ones should we try? I would never try x plus 7. Because 7 as a last number never works out to be part of 12. I might have tried x plus 6, because 6 is a factor of 12. I might have tried x minus 2, because 2 is a factor of 12. So the factor property, which is on the bottom of the page after this example, wow, my thing is off. The factor property is saying this, is saying that if something's going to be a factor of the whole thing, then that value of a has to be a factor of our constant term. So when we go here to example 3, which says let's factor this one fully, if we think of all the way to the end, our last term here is a 2. What are the factors of 2? 1 and 2. Or plus or minus 1 and plus or minus 2. Could be positive, could be negative. So we only have 4 choices of factors here. We have our choices if it's plus or minus 1 or plus or minus 2. Now with the 1s, you might want to use your remainder theorem. I'm going to let p of x equal this whole thing, so I don't have to write the whole thing over and over again. And it also allows me to use some function notation by saying, what's p of 1? And maybe you get lucky on your very first try and you get a remainder of 0. So if I plug in 1, I'm going to get 3 minus 4 minus 5 plus 2, which is equal to minus 4. That tells us that x minus 1 is not a factor. So which one am I going to try next? I'll probably try p of negative 1. That one's going to be easy to do mental math-wise. Negative 1 cubed is still negative, so I'd have negative 3 minus 4 plus 5 plus 2. And that's equal to 0. Does this block more of the screen? So x plus 1 is a factor. And as soon as you find one factor, then you can use synthetic division to break it down. So I found out that x plus 1 is a factor. I'm going to divide 3x cubed minus 4x squared minus 5x plus 2. Oh, this is going to bug me all day. There we go. There can be more than one factor. But once we find one of them, what we're going to do is we're going to look at its 3, -4, -5, 2. Just going to double check anything missing, no values missing, everything's in the right order, good. And if I'm dividing by x plus 1, what value do I put out here for synthetic division? -1. I'll bring down the 3, multiply, add, multiply, add, multiply, add. And we needed to have that happen, right? We needed that remainder to be 0. This is finding the remainder as well, but it tells us a lot more. Because if we now write our division statement, and I'm going to write p of x equals, because I said right at the beginning, let p of x equal the whole thing. Saves me a little bit of time writing things. That means that p of x is equal to x plus 1, because that's what we were dividing by, multiplied by 3x squared minus 7x plus 2. So this is our polynomial equals dq, Dairy Queen, and plus remainder isn't written because our remainder is 0. I mean, you could write plus 0 there, but it wouldn't be necessary. And the question said factor fully. We've partially factored it, but now to factor it fully, this is a quadratic. You know how to factor that. The only way to get a 3x squared is a 3x and an x. I need to get 2, so I need to have a 1 and a 2. I need to put my 2 here, so my outside is 6, and my 1 there, so my inside is 1. I need to get a -7, so I need them both to be negative. And now we've factored it fully. So we found x plus 1 as our factor first, and then solved it from there. Maybe you decided to use 2 before you used -1. If you would have plugged in 2, same thing. You would have found it equal to 0, and you could have done the same steps. So as far as a recap of what we did, right? The very first thing we needed to do was find one factor. And you could find that factor by using the remainder theorem we defined one factor by using the remainder theorem or synthetic division. We used the remainder theorem. You could have checked each one with synthetic division as well. The next thing that we did we used our synthetic division to start our factoring. And we wrote the division statement. Now sometimes, like in this case, we could finish our factoring because we ended up with a quadratic and we knew how to factor that. But if you started with an x to the 4, do you see that you would break it down and get to an x cubed? So step 3 is either you have to repeat this process again, or you have to factor the remaining quadratic. So in our case, we got to a quadratic. You know how to factor that already. But if you factored an x to the 4 and you ended up with an x to the cube, you would have to do this process again with your new x to the cube to try to factor it. And you would repeat the process until you get down to a quadratic, which you could factor further. Okay, I'm going to give you some time to try some of these, and then I have a few other ones that I'm going to get you to do. I want you to do them in this order: 5, 11, 9, and then 10b.